Let us begin our discussion by the term conversion. In other words, the conversion of a reaction can also be called as the progress bar of a reaction. We know that the values in a progress bar ranges from 0 to all the way to 100. That represents complete progress of any process, right? In the same manner, we are measuring the conversion of a reaction in terms of quantity of limiting reactant that has been consumed. So it is the quantity of limiting reactant that we are measuring, and we are tracking the progress of consumption of this limiting reactant. For example, let us suppose that we have a reaction nitrogen plus 3 moles of hydrogen giving us 2 moles of ammonia. Alright, let us suppose that initially we have 6 moles of nitrogen in the reactor, whereas let us suppose that we have 10 moles of hydrogen in the reactor and initially there is no ammonia in the reactor. Now, after a certain time, what we observe is that there is only 4 moles of nitrogen remaining inside the reactor. So, if we do calculations on the basis of this observation, then we can conclude that the moles of nitrogen has changed from 6 moles to 4 moles, and hence we can conclude that 2 moles of nitrogen have been consumed in this process during the reaction, right? Similarly, if 2 moles of nitrogen has been consumed, then we can conclude that 6 moles of hydrogen must have been consumed during the reaction, and this will give us the remaining amount of hydrogen to be 4 moles. And in the same manner, since 2 moles of nitrogen has been consumed, it will return to us that 4 moles of ammonia has been produced in the reactor. So the amount of ammonia will be 4 moles after this much reaction. Okay. Now we would like to estimate the progress of the reaction while this reaction has happened so far. Alright, and we have to identify the limiting reactant for this case. So, for nitrogen and hydrogen, we will do the calculations that 1 mole of nitrogen requires 3 moles of hydrogen, and therefore 6 moles of nitrogen will require 18 moles of hydrogen, and we can check that we have only 10 moles of hydrogen in the reactor, right? And hence we can conclude that hydrogen is the limiting reactant in this case. Alright, so now as we discussed, if the limiting reactant has been consumed completely, then it will be 100% progress of reaction. So here we will see that how much of limiting reactant has been consumed so far, and this will give us the progress of the reaction. Okay, and hence we will express the conversion for this reaction as amount of hydrogen consumed divided by initial amount of hydrogen present. Okay, initial amount of hydrogen present. So we can see that initially there was 10 moles of hydrogen, and out of this 10 moles 6 moles has been consumed, and hence the conversion for this reaction will be 6 upon 10. Okay, we can also express this conversion in terms of percentage by multiplying it with 100, and hence let us move onwards and write the general definition of conversion. Conversion of a reaction is equal to amount of limiting reactant consumed divided by initial amount of limiting reactant times 100. Okay, so this multiplication by the factor 100 converts the entire ratio in terms of percentage. So this is the general formula for calculation of conversion. All right, so let us revisit the problem once again and note down the steps of calculations in which we have performed this calculation. So first of all, this many number of moles was given to us, 6 moles of nitrogen, and also we were provided that how much of nitrogen is present in the reactor after the reaction has happened. Alright, on the basis of these two informations, we calculated the amount of nitrogen that has been consumed. Okay, let me mark this step as A. And following this, we calculated the amount of hydrogen that must have been consumed, and let me mark this step as B. And following this, we finally calculated the amount of hydrogen that is remaining in the reactor. Okay, so we have proceeded in this manner. First of all, we performed the calculation A, then B, and then C. Also, we calculated the amount of ammonia that is formed, and let me mark it as D. This step is independent of B or C. We can directly calculate D from the step number A also. Alright. So thank you, and let us move ahead for the next topic.